So in 2000, I wrote this online suite of PSI-tests. This is more for entertainment rather than for rigorous experimentation, but some of these experiments have hidden tasks in them which actually make them useful for psi experiments. And I'm slowly going through these almost 20 years of data now and reporting the results. So the one I'm going to talk about today is, we have 228 million trials as of a few days ago, and 354,000 people have done the test. This was done in conjunction with Richard Schaup, or Dick Schaup as we called him, who passed away a few years ago. So I'm talking about the location test. This is kind of a dowsing test. So it works like this. You go to the browser screen, you see this blue square, and you have to select in a 300 by 300 matrix space where you think the computer will choose a random spot. So you're doing like a map dowsing test. After you choose a spot, the computer selects the location, and it's indicated with this red dot. So the distance is what we're looking at for the main measure. So here's two examples of showing that we figured out a way of adjusting the results on each trial so that you couldn't maximize it based on where you touched. So in this case, the touch and the target were quite close, and the odds against chance are 89-1. So in this case, they're also quite close, but the odds are only 26-1. And so the way that you adjust it is based on where in the target you select, and you just go through all 90,000 possible locations, and you figure out the mean and the standard deviation of each one. And so when you select a point on the screen, you'll get a distance. You compare it to the mean and standard deviation, so you get a z-score for every single trial, and the z-scores are valid. So from July 2002, when we launched the final version of this test, to December 2018, 63 million trials, 5,749 days, which is not, we missed a few days. Occasionally we would switch servers, we'd fiddle with the program in some way. So we have almost all of the days, and about 120,000 people have done this test. So the reason why the location test is interesting, especially for looking for geomagnetic correlates, is because if you locate yourself in space, that's what this task is. It is, in a sense, a navigational task, even though it's map dowsing. And we know from recent studies now that for much of the 20th century, magnetoreception research seemed as unsavory as the study of dowsing or telepathy. Well, here we're studying a kind of dowsing telepathy thing. So it may be unsavory for science, but not for us. Yet, it is now an accepted fact that many animals sense the always-on, barely there magnetic field of the Earth. And now increasing evidence that this is also true for humans. So there's the magnetosphere, for those of you who don't recognize it. It's always there. It's always being buffeted by solar particles. So it's moving around constantly. Here's a scientist, I think from UCLA, who thinks he discovered a magnetic sixth sense in humans using a very fancy setup. But this has actually been known for quite a while now, that some humans are very good at magneto navigation. So the overall z-score from the 5,749 days, 16 years of data, is not significant. It's in the predicted direction. The negative score means that the distances are smaller than you would expect by chance, but it's not a significant result. And this is where we put the non-significant results, in the file drawer. So my interest here was what is happening in terms of the geomagnetic field as a possible correlate for this kind of task. And so we go to the Space Weather Prediction Center, where you can go to a FTP site and download data from every day for many, many years. And so here we go with the location test performance per day versus the global AP index. And what you see is there it actually is quite a significant correlation. It's 2 days before each test. But even on the day of the test itself, you have a significant correlation. The correlations here are positive, and if those of you who remember there's a negative correlation between ESP results and the geomagnetic field. The reason here it's positive is because what we're looking for are negative z-scores. We're looking for smaller distances. So that's why we end up with a positive correlation. So the negative correlation between anomalous cognition scores and geomagnetic field fluctuations constitutes the first and currently only known physical correlate to anomalous cognition performance. So said James Spottiswoode in 1990 in a review article. And so there's a picture of James Spottiswoode. Oh, wait a minute. That's the James Spottiswoode from 1600. This is the one that I mean, this James Spottiswoode. So we also have other data that we can look at. Since the geomagnetic field is pushed primarily, not all, but primarily by solar particles, we can look at things like proton fluence per centimeter squared at greater than 1 megavolt or mega electron volts. And there we see something that looks very similar to the geomagnetic field. So it's not too surprising since those two are correlated. We can do the same for higher energy particles, like 10 mega electron volts, and you see something that looks kind of like what we see with lower energy. And you can even go higher, so greater than 100 mega electron volts, and now the effect reverses. I have no idea what this means, but this is what you get when you start playing with these geocosmic factors. Maybe it's meaningful, maybe it's a coincidence, except that it actually is statistically significant. So the conclusion on all this is on a map dowsing task. We see a 2-day, actually on the day of the test and day after, or the day before, no, sorry, the day after and 2 days after, you do get a significant correlation with the geomagnetic field. So there's something about the magnetic field that we're sensitive to and is interacting with this task in a nice way. And there I put in a picture of the sun just because it looks nice. And that'll stop there. Thank you.